Okay, cool. All right. One of the things I continue to hear students say, and yes, one student lives in my home, is this is stupid. Why do we have to do this? So I have made. Yeah, you don't have to think real hard. But I've been really researching why do we want to do this? Why do we want to look at it? And we're going to talk about slope today, which I know you've seen many, many times. But I found two interesting applications. And an avalanche, you actually have to understand slope in order to be concerned with whether the terrain you want to ski on has the potential to have an avalanche. And what I came across is it says most avalanches occur on slopes between 35 and 45 degrees. Slopes less than 30 degrees seldom produce avalanches, and slopes steeper than about 50 degrees, they slough off so often that they don't tend to build up into the slabs that cause an avalanche. So it's the intermediate slope steepness that produces most of the avalanches. But the bad news is that exactly the kind of slopes we like to ski, snowboard, or snowmobile usually produce the most avalanches. A black diamond slope at a ski resort is usually around 35 degrees, prime steepness for producing avalanches. And I found that so fascinating. The other area is pitch of a roof. Roof pitch is the measure of a roof's slope or angle of incline. Is there really a difference between pitch and slope? And the answer I found is yes and no. To understand how to properly use these terms, a brief lesson in roof geometry helps. Pitch is expressed as a fraction such as 1/4, each number representing the coordinates of an angle. So if you had a roof of 1/4, it's really to the right 1 up 4, kind of thing. The angle is based on a roof's rise and span, so it really is your rise over the run. Say your house is 38 feet wide, and the gable roof has a 1-foot overhang. So what they're saying is like from here to here is 38, but then you know how you can have that overhang a foot and a foot, makes it really a total span of 40 feet. And let's say the highest height is 10 feet. So it's really like 10 over 40, which reduces to 1/4. So a 4-inch 12 pitch means the roof rises 4 inches for every 12 inches going a horizontal distance. The word pitch was first used in the early 17th century to denote the highest point. This referred to everything from musical sound to the height that a falcon reaches before swooping down to attack its prey. So I thought that's just very interesting. All right. Did you know René Descartes, a French mathematician, used m for slope from the French verb monter, which means to mount, to climb, or to rise. So when we talk about y equals mx plus b, Descartes is the one who started using it, and it was widely accepted. Okay. All right, so here we go. 1.2 notes. The formula for slope, you know this, y2 minus y1 divided by x2 minus x1. The standard form of a line is ax plus by equals c. And slope-intercept form of a line is y equals mx plus b. We know that. So in example 1, if we want to sketch the graph of each linear equation, in letter A, this one is in y equals mx plus b form. So you want to plot the y-intercept and use the slope. In B, this one's standard form, and you can easily do the intercepts. Make a little table. So if I plot the y-intercept is 1, and then I go up 2, right 1, up 2, right 1, And then remember what we talked about yesterday. We need to always include the interesting parts of a graph. You can tell the y-intercept just from the equation is 0, 1. Now we refreshed our memory yesterday. How do you find an x-intercept? Rachel? Good. Plug in 0 for y and solve for x. So I would subtract 1, divide by 2. So I have an x-intercept of -1/2, 0. And you can see my line is really hitting that. Okay, now in this next one, what I mentioned, when you have standard form, it's oftentimes easiest to just, you don't have to solve for y equals mx plus b. So I can cover up the x, y is 2, I can cover up the y, and x is 2. So I plot these two, and so this is your y-intercept and your x-intercept. Looking at this graph, what can you tell me about the slope? It's negative, right? Because the line is falling as I move from left to right. And what's interesting is, you can solve for y equals mx plus b. There's nothing wrong with that, but sometimes it's more work than you need to do. But if I subtracted x, do you see it have y equals -x plus 2? It is a negative slope. All right, letter C. Y equals 2. This is one of our special lines. What kind of a line is it? It's a horizontal line. So we're going to go up to y equals 2. And if it helps you, remember that y can look like an upside down H, if that might help. And then how about x equals -3? What kind of line is that? It's a vertical, and if it helps you to think of that as two V's coming together. The general form of a vertical line is x equals a number. The general form of a horizontal line is y equals a number. All right, I want you to try example 2 on your own. Find the slope of all 4 of those. All right, go ahead and check your answers with mine. Letter A, I got 1/5. In B and D, I want us to focus here a moment. It is not acceptable to leave 0/3. Why would I say that? Why can't we leave 0 divided by 3 and say that's the slope?
Because you still move 3 to the right, cause over 1. It wouldn't make any sense because it's not supposed to.
Okay, that's definitely true. Definitely true. You go up nowhere and you go to the right 3. John, did you have something else? You said you can't divide by 0. When we're in B, we're not dividing by 0. it's really coming down to just, okay, you can 0 divided by 3 has a simplified answer. Like if I said 10 divided by 2, we never leave 10 divided by 2. You would reduce that to 5, okay? And then C, M was -5, and in D, you can't, John was right, you can't divide by 0, but -3 divided by 0 is not a simplified answer. That says to me that a student doesn't understand. It means it's undefined. And let's go back to, I like what Ben was saying there, is think for a moment, if I were to plot let's say I plot these, and I have -1, 2, and 2, 2. Okay, let's connect this to what he was talking about. If slope is rise over the run, you don't go up anywhere. Now you went to the right 3, but it's still slope 0. And then when I go and I look at letter D, so I plot 3, 4, 3, 1. Now think about slope graphically. If it's rise over the run and you start rising, it's almost like it's out of control and you can't stop. So you're rising uncontrollably. You understand then that that's why it's undefined? You don't ever get to turn off. I oftentimes think of a roller coaster, one of those that just takes you up and then drops you. It's like imagining you're on that roller coaster that's not really a roller coaster, but the ride is just shooting you straight up and you can't get off, okay? So, that's telling you there's something wrong. So all vertical lines have slope that's undefined, and all horizontal lines have slope equal to 0. All right, example 3 says find the slope and y-intercept of the line with equation 3x minus 4y equals 12. Does anybody want to give a suggestion? How might we figure that out? Tyler?
You could just put it in slope intercept form and then get like this. So put y on one side.
Exactly. So rewrite it in slope-intercept form. Y equals mx plus b. So let's subtract the 3x from both sides. And then let's divide by -4. And I get y equals 3/4 x minus 3. Then we can just read off the slope and the y-intercept. My slope is 3/4, and my y-intercept is -3. Any questions on that one? In example 4, I'm going to go a different route this year with you than I did last year. It says, write an equation of the line with slope m equals 3 and passes through the point 1, -2. We have something, and we did see it last year, but we didn't emphasize it quite so much. We have point slope form, and that's a T, sorry, my pen kind of hooked on it. Y minus y sub 1 equals m times the quantity x minus x sub 1. So this is my x sub 1, y sub 1, and there's my m. So watch what I can do. I would get y minus -2 equals 3 times the quantity x minus 1. So I get y plus 2 equals 3x minus 3, and then I just subtract the 2, and you get y equals 3x minus 5. You can still use what we did last year with y equals mx plus b, plug in x, y, m, and find b. There's nothing wrong with that, but this is, I'll tell you, in AP Calculus, we use point slope a lot more often. So I thought if we can just practice it, it might make your lives a little bit easier. So in example 5, if you want to write an equation of the line that goes through 4, 3 and -4, -4, all we're going to do is find the slope and then do it again with one of the points. So I get negative 4 minus 3 over negative 4 minus 4. That's negative 7 over negative 8. And the negatives cancel, so it's positive 7/8. I'm going to pick the positive 4 comma 3 and then use point slope. Y minus 3 equals 7/8 times x minus 4. Now, you've got this fraction, and you can work it an easy way or you can work it a difficult way. The easy way is take whatever's in the denominator and multiply. So I get 8y minus 24 equals, and now watch, the 8's cancel, and I just need to distribute the 7. So I get 7x minus 28. So I get 8y equals 7x minus 4, and then divide by 8. So y equals 7/8 x minus 1/2. And something I'd like you to practice this year is stopping and thinking about your answer. Does your answer make sense? We found a slope of 7/8. If you did this and got y equals 7x, there should be a red flag that says, uh-oh, we made a mistake somewhere. Okay, so really pausing when you're done with a problem and thinking about it. All right, then example 6. We've done this many, many times, Algebra 1 and Algebra 2. Find an equation of the line that passes through 2, -1 and is parallel to, then perpendicular to, the line 2x minus 3y equals 5. So the first thing we need to do is we need to find out what the slope is. So we're going to solve it for y equals mx plus b. And I did that rather quickly. But the m is 2/3. So if we have a parallel line, we know that parallel lines have the same slope. So we're going to practice point slope again. And are you guys okay with y minus -1 becomes y plus 1 equals 2/3 times the quantity x minus 2. When you have a pesky fraction, we can just multiply by that denominator, and I get 3y plus 3 equals, the 3's cancel, but I do have to distribute the 2. So I get 2x minus 4. I'll subtract 3. And get y equals 2/3 x minus, and that's 7/3. In case you can't read it, that is a 7/3. In letter B, if I want it perpendicular, what would be the slope? John, what would be the slope if it's 2/3? What's a perpendicular slope? Good job. It's the opposite reciprocal. So this becomes y plus 1 equals -3/2 x minus 2. It's the same point. I'm going to get rid of that denominator, so I'll multiply by 2 and get 2y plus 2. And then we're going to distribute the minus. Let's subtract the 2 and then divide by 2. So y equals -3/2 x plus 2. All right, last one, example 7. Write an equation of a line with x-intercept 1, 0 and y-intercept 0, -4. Alright, take a moment. I want you to think about it and see if you can figure this one out. I'm seeing some wonderful things on your papers. Wonderful. Alright, does anybody want to explain what they did? I saw some fabulous stuff. Anyone? Rachel, what'd you do?
Well, I did so. Did -4 minus 0 and then 1 minus 0.
Okay.
And then I knew, well, that's -3, so just 4.
Wait, -4 minus 0, then it has to be 0. So that's 4, right? Okay, then what'd you do?
I knew my y-intercept was -4, so it's y equals 4x minus 4.
Good. Okay. I like what I saw on Lydia's paper. Lydia, tell me, what did you do? She graphed it, okay? Okay, she did this. She's like, all right, I got a point right here. And she's got a point right there. So, you know, I loved that. You've got the y-intercept, the b, and then rise over the run. Your m is 4. You know what's interesting? Did anybody else do it a different way? In the other class, Scott did his completely different. What he did is he took the 2 points and plugged both of them into y equals mx plus b. So he said 0 equals 1 m times 1 plus b. And then he took the other one and he said -4 equals 0 times m plus b. But that produced b was -4. He plugged it in and got that m would have to be 4. Do you know what he was doing here? This is something you've done in Algebra 1 and Algebra 2. He didn't realize he was doing it. That's a system of equations, isn't it? And I was like, how cool. So we saw it graphing, we saw y equals mx plus b, and we saw even a system of equations. So there's not just one way to do that.